And today we're going to look at this robot, or at least the frame of this robot, which I have made for the past year. As you can see, I only really have one motor on it right now. There are more motors, but I had to take off all the motors because previous times when I was testing it, the motors broke off and I had to fix them for their mounting solution. So this is the motor that goes in this place. So before, it was just this round part was being held in to this little conduit hook. Here's an example of one here. So it was basically just like that, and that hooked on just fine. But the problem is that all the load was being put through this motor, and this motor is only connected to the gearbox by two small bolts. So really you want to hook it by this place right here, which is the actual bearing part. So it's much stronger here, but I'm gonna hook it in on both places as well, just to keep it stable. So there were a few motors. I actually broke one of the motors. This motor right here, well, it went in kind of like this, but this used to be on one of the legs right here. But the problem was that it was only hooked in by the bolts once again, and it broke off. So you can see, there's a huge gap here, so that's the problem with using those motors. But if we turn this robot around, this robot is supposed to walk. It doesn't. I've never really gotten it to walk just right, but I have gotten it to shift its weight with the motor, which, well, it used to be in the center. So right now I have just finished fixing up how to mount this motor right here. So you can see it's hooked in on the baseline and by here. So how this robot is supposed to work is it has linear actuators like this one. So the motor is connected to this 1/4 inch bolt. This is a cordless drill motor, so it has a little end. So the ending of it is kind of like this. So there's a little thing here, and basically what I had to do is I had to file down this piece to fit inside of here, and just kind of forced it in place and sealed it up with hot glue. The hot glue just keeps it in place. It doesn't actually bear any load. Same here. I have two bolts here, one on the top, one on the bottom, connected to this little L bracket. So same thing here. The bolts are connected by metal on metal, and the hot glue just keeps it in place. As far as the arms, this robot does have some arms, which just kind of, they don't have very much going on here. So it has the palm of its hand right here, and there's the elbow joint here, and the robot can open it up like this. Problem is you can't do it like these ways, but I want to fix that just when I can get better controls into this robot. So let's take a look at some more motors and control elements of this robot, aside from just the basic aluminum structure. The most important part of building a robot, especially where a bipedal humanoid robot is your ability to move from side to side. This is accomplished by the motor, which is here. So we're viewing this robot to have it go. It's supposed to slide right in here, which I'm working on putting that back, but what it does is it shifts a counterweight or a big weight, which is just a piece of metal with some bolts. So this is connected to this motor and shifts it from side to side, which makes the robot go from side to side. But with a motor like this, I had some issues controlling it. So basically what I did is I had an interesting setup with a switch, and the switch would turn on and off, and that connected to some relays which would make it go back and forth. It would lose track and it would often go upside down because of the weight would just shift it. Like, this acts as a huge lever, so this puts a lot of force on the motor, which makes it go upside down, and it just went in circles. And well, I guess let me show you that mechanism right now. So we can move our little robot aside and focus now on the desk, which I'm going to bring out our pieces for this robot. This is a very messy design. It was just to get it to work. So remember, now we have to get the motor to go from side to side. So basically is this Lego box, and it connected to the Lego motor, and it would turn the switch on and off. So you can see, like, there's gears. And that would, it's not powered on right now, in fact, because I'm going to change it out with the better system. That's why this entire robot is in pieces. So we'll switch these two relays, and whenever these, so these are both dual throw single position relays, single pole relays. So I got two of them together, what effectively makes a DP-DT relay. I just soldered some wires on there, and that would make the motor go. Not very well, but it did do some stuff. So I'm gonna pull out a notebook right here, and we're gonna try to design a better system. Okay, so with the junk aside, let's break this down a little bit. So we have our robot, which I'm just going to draw what it is. It's a set of legs. The torso doesn't really matter as far as the walking goes, which is the function that I'm trying to get going the most right now. The arms will actually be pretty easy to do later, as long as we can get it balanced right, which might be a hard thing to do, but it should be adjustable, which is how I'm going to make it. So this robot, we got our set of legs and a motor here, and that motor has a huge weight on it. And we want the weight to go back and forth between two known distances. And how I had it before is I just had a piece of pipe here, so the motor would just hit the pipe, and that would prevent it from going off into distances. Literally, this circuit was the only thing controlling the robot. As mentioned before, it did not really walk, it just shifted its weight back and forth, which was most of the function that it needs to do. But I want to do it better. So instead of just having two pieces of pipe right here, we can have an actual sensor bar. So there's a switch here. So there's the switches, and these are going to be momentary switches because this thing is going back and forth. It only hits it momentarily, but we want them to go into a flip-flop. And by a flip-flop, I'm not talking about the sandals, I'm talking about the electronic circuit, which has the set and reset function, which, let me draw it out. It's basically two not OR gates, and they're going into each other, so we have a set and a reset, and the input of one goes to the output of the other, and the output of one goes into the input of another. So when the set is turned on, one of these will turn on, and when the reset is on, one of these will turn on, and they will stay on. So we can use that circuit connected to either these relays, some other relays, a power transistor, etc. And that should give us some basic feedback function for when we have it like that. Also, we could have a rotary encoder or something of that sort with, example, a photocell and an LED. So we have our LED and our photocell or photoresistor. And whenever something passes between them, it will interrupt the circuit. And that could be this thing. So we want to be able to track this very precisely throughout its movement. If we just put the switches here, we can determine whether it's here or here, and we can just adjust the position of these two objects by hand until the point where they're balanced. Or we could have some feedback which is more direct, such as this thing. And how we can get this to work is basically we have our photocell, which is essentially a resistor that's determined by light, and we could have another normal resistor in here, and this will be a voltage divider, and that can go into a transistor, which will give us an output value. And that can go into a microcontroller, and we can have this set up a little bit better. As far as for the motors on the legs, I'm going to put a motor on this other leg first, the one that already has the motor, and they'll all be on the top leg section, not on the bottom leg section, because I only have limited motor supply right now. So when I get motors, I could put them there. And maybe we could do some testing just with our 3D motor setup. As far as the arms go, the arms, as I mentioned, have limited motion. I would like to correct this, and we can do that. I'll make videos on that in the future.